Hi, welcome to our lesson 2-3. Today we're going to be talking about, as you can see, measures of center and spread. We've already talked a little bit about the measures of center that are appropriate for various graphs. Today we just want to refresh your memory about what measures of center are and how to find them. And we also want to talk a little bit about how you talk about the spread in a distribution. So I have a couple of graphics here that I really like, and here's what I'd like to show you. The mean of a data set, folks, is the spot in the data set, or the number that splits it in equal value. Think equal weight on each side. This side weighs as much as this, or many people call that fulcrum the balance point. That is, if we can find the exact mean, and we could take that right out of the paper, that's where it would balance if we stuck our finger right there, right? The mean talks about equal value on each side. The median, on the other hand, is not talking about value, but the median says, okay, I have an equal number of items on each side. Remember, the median is halfway through the data set, so 50% is on this side, 50% is on that side. Not the same thing, okay? Not the same thing at all. Our book doesn't make a big deal about mode because they assume that we all realize the mode is the highest or most often occurring point in a data set. It is not really a good numerical measure of anything, so it's not talked about a lot in our work. Suppose we had 5 third graders, all of them about 4 feet tall. They're standing in line, perhaps, when their teacher, who's 6 feet tall, that could have been, by the way, my daughter's 5th grade teacher, was extremely tall, she joined the group. And it says, what's the new mean height? Well, before we know about the new mean, we should find the old mean. If we have 5 third graders, all 4 feet tall, that means that the total number of feet would be 5 times 4, split among 5 people, obviously. The average, or the mean, originally would have been 4 feet tall, which sort of makes sense. When the 6-foot teacher joins them, instead of then having 5 times 4, they now have another 6 feet added to it, and now we're splitting between 6 people. So 26 divided by 6, about 4 1/3. I guess I could have done that without reaching for the calculator. 4 1/3 feet. See, that teacher, who is so much taller than the other students, really changed the mean by quite a bit. The new median height, on the other hand, well, we had 5 third graders, all 4 feet tall. So I'm going to just write them 4, 4, 4, 4, 4. There they are. And here she is, 6 feet tall. The median would be the center spot in this sorted list, and since it has an even number of values, you know that if you remember the rules, you add the 2 together and divide by 2, so we're 4 plus 4 over 2, which, geez, is still 4. See, when that teacher joined the group, yeah, the average height, the mean height changed. The median didn't, because she's just one more person in the list, right? The mean, folks, is much more sensitive to extreme values, much more sensitive to extremes. Okay, it can really change by a lot. So we have to be careful when we're talking about the mean, and just keep that in mind. All right. We want to take a look, so that was our discussion on center. We want to take a look at 2 different ways of measuring the spread of a distribution. The range, folks, which is found by taking the maximum value minus the minimum value. It gives you a numeric way to say where my data falls between. See, it makes more sense to me to say you find it by doing max minus min, but giving the values of those 2 numbers and then saying how far apart they are makes better sense to me. Anyway, the range, which is maximum minus minimum, and the interquartile range of a data set. Now, IQR is the initial for that, and what that means is, we talked about the quartiles the other day. If we take Q3 minus Q1, that's known as the interquartile range, and I hope you'll remember that it has the middle 50% of data values. The middle 50% of values will be in there. All right. The range just tells you overall the two numbers that your data lie between. So let's see. It says that we should find the range, the quartiles, and the IQR for the ages of the hourly workers at Westvaco before and after that round of layoffs, round 2. So we have them in sorted order here. It shouldn't be too hard for us to find the range. That would be 64 minus 25, or 39 years. Again, to me it makes more sense to say there's a range of 39 years in ages from 25 to 64. It's more descriptive. The median for this would be, let's see, the data value that splits it into 2 equal pieces. So we have 1, 2, we have 5, we have 10 workers there. So we want to split them so that they're equally weighted on both sides. That means, and since we had an even number of values, we have to take 48 plus 55 and divide by 2. 48 plus 55 is 103 over 2, or 51 and a half. Okay, that's the median age, 51 and a half. The lower quartile, if you'll recall, Q1 is the median of the lower part of this data set. And folks, it has 5 pieces on each side. 35 is that quartile. The upper quartile, 55, it's the median of the upper part of that set. The range is 39 years. That is, the ages range from 25 to 64, which is 39 years overall. The median age was 51 and a half for these workers, with a lower quartile of 35 and upper quartile of 55. What's important to me is that we remember the middle 50% of the values are contained between those two numbers. The middle 50%. Okay. Let's see where we're going from here. The numbers that you just found, including the median, the max, the min, and the quartiles, along with the mean, can be found in your calculator's varstat function. So if you put these data values in your list 1 and choose one varstats, it's stat over to calc and enter or choose. It's called one variable statistics, one varstat. Okay. As long as your data is in list 1, you can just hit enter. If it's in a different list, you would have to specify the list number. But that one varstat is going to be our friend, folks. We're not going to want to go around counting to find the median of data sets. It's much simpler, I think, to let the technology do it for us. We're supposed to be about analyzing numbers, right? Not about crunching them so much. The 5-number summary for a data set. Important that we get this. The 5-number summary, it's called. It consists of these values that we just talked about. The minimum value, the first quartile, the median, which, by the way, could also be called Q2. Some places they do call that. Q3, and the maximum. The 5-number summary can always be displayed in a graphical display that some of you will remember called a box and whiskers plot, or just a box plot. Many people call it box and whiskers because it kind of looks like that when you're finished. If we wanted, we could create a box plot for the ages of those Westvaco workers. It is a graph, so it needs to have a title. These are hourly worker ages. And a box plot is built on a number line. Not everyone always shows the number line, but it's part of the deal. Folks, I'm going to go back and look at that data set for a minute so that I know how to number my axis. All right. I got to go from a low of 25 to a high of 64, probably 20 to 70 maybe. And then I want to remember my 5-number summary. 25, 35, 51 and a half, 55, and the max of 64. I know I'll never remember those. All right, we're going to number from 20, 30, 40, 50, 60. Our youngest worker was 25. He gets a little whisker out there. Our oldest was 64. Is that right? Yep, 64. Our oldest was 64. So here's the other end of that. The way I draw the box plot, I'm going to put the median of 51.5 in here. The upper quartile was 53. The lower quartile was 35. The box surrounds the median. The whiskers go out to the min and max. Okay. If you so desire, some people put the values here. It's certainly not necessary. Some people draw them vertically, so the number line would be on the y-axis and it would be going up and down. That's fine too. I choose this way because this is what the calculator shows. So that's the box and whisker. And by definition, a data value is considered to be an outlier if it is beyond 1.5 times the IQR from either Q1 or Q3. Folks, that's kind of an odd definition. So you take the value of the inner quartile range, you multiply by 1.5. Then you subtract that from Q1 and you add it to Q3. And then if your data values lie outside of those boundaries, they are considered to be statistical outliers. The 5-number summary here, this is from a data set that's in your textbook. I'm going to get my calculator because I can. Okay, I have those data values entered into my calculator. 38 animals there, and that's just right because this says it's waiting for the 39th one. The 5-number summary, stat, over to calc, 1 variable stats. As long as your stuff is in list 1, you're good to just go ahead and calculate here. And the 5-number summary for this data set, you don't see it here. However, if you arrow down, that arrow tells you that there's more. Here it comes. Okay, we had a minimum of 1. Q1 was 8. The median is 12. Q3 is 15. And our max is 41. The IQR will be the difference between Q1 and Q3. I'll write the workout. That's 15 minus 8, or 7. To find if we have outliers, we're going to multiply our 7 by 1.5, subtract it from the first quartile. So 7 times 1.5 is 10.5. So we need Q1, which is 8, minus 10.5, and that's negative 1.5. We need Q3, which was 15, plus 10.5. That puts us at 25.5. And if we get an animal whose longevity is less than this or more than this, then we have an outlier. Well, this one, the bottom limit, we're not going to cross because we don't have anybody that gets negative life. But we do have some outliers here. Anybody bigger than 25.5. So that would be this one, 35, and 41. We had 2 outliers. 2 data pieces, 35 and 41, are beyond that range. A modified box plot, folks. What a modified box plot does is this. It shows outliers as asterisks. The whisker becomes the next lower or higher data value. You can choose this on the TI-83, and that's what I'd like to show you here. Second and y equals for statistical plots. second and y equals, she said. We want to enter on plot 1, and we want to choose the box plot that's got the dots on it. See it there? Whoops. It is the fourth option. And I'm going to go ahead and set my window from 0 to 45. I'd like to set my own windows. You could zoom 9 for sure, but the problem there is that we lose track of where we're at. And by the way, the y's don't matter when you're doing a box plot. I'm going to set the low at 0, however, so that I don't get an axis showing. As I was saying, if we don't set our own windows, we let the computer do it for us, then what happens is we forget the part of the data that we're looking at. Here's our modified box plot. Notice the two outliers, just like we thought, 35 and 41. The whisker becomes the next lowest number, and in this data set that would be a 25. So it looks way less skewed when you realize those outliers, if they weren't there, that would be kind of, well, it looks like it's pretty symmetric. However, with the outliers in, not very symmetric at all. All right, that's our lesson for today, and I hope that you'll get out there soon and do that you try. Remember, it's due before school tomorrow. It's how I decide what we talk about in the first few minutes of class. See you then. Bye-bye.